Your computer is doing something to you right now and you do not know it. While you sit here watching this video, Windows is running processes in the background that you never turned on, never asked for, and almost certainly never knew existed. These processes are not doing anything useful for you. They're not making your computer faster. They're not protecting your security. They are eating your CPU cycles, spinning your fan harder than it should be spinning, and in some cases, pushing temperatures to the point where the processor itself is forced to slow down just to stop itself from cooking. This is called thermal throttling, and it is one of the most invisible performance killers in computing. Your computer quietly gets slower, hotter, and shorter lived. And most people never connect those symptoms back to a handful of background Windows services that can be stopped in about 10 minutes. I have stopped 5 of them on my own machine. I am going to show you exactly which ones they are, exactly what they are doing to your hardware, and exactly how to disable them step by step. No guesswork, no vague advice, just the 5 specific things I turned off and why every single one of them earned its place on this list. But before we touch a single setting, let me give you the temperature context that makes this conversation worth having. Because understanding what numbers actually mean for your CPU is what separates a useful fix from just randomly clicking things and hoping for the best. Modern desktop CPUs are designed to operate safely within specific temperature ranges. At idle, meaning when your computer is just sitting at the desktop with nothing demanding running, your processor should be somewhere between 30 and 50 degrees Celsius. That is a healthy idle. When you're doing real work, gaming, rendering, editing video, compressing files, safe temperatures run between 60 and 85 degrees Celsius. At 85 to 90 degrees, most CPUs enter what is called a warning zone, where performance can begin to suffer and the system starts working hard to pull heat away. Above 95 degrees Celsius, you are in danger territory. Intel's newer processors have a maximum junction temperature called TJ Max that ranges between 100 and 105 degrees Celsius. AMD's newer Ryzen CPUs have a TJ Max that ranges between 89 and 95 degrees Celsius. When your processor hits those numbers, 2 things happen. First, it throttles itself, meaning it deliberately drops its own clock speed to generate less heat. Your computer slows down to protect itself. And if temperatures keep rising after throttling, and the CPU still cannot shed enough heat, it performs an automatic emergency shutdown to prevent permanent physical damage. That last part does not happen often with modern systems, but the throttling absolutely does. And it absolutely happens to people who never realize it, because the computer never tells you it is throttling. It just quietly becomes 15, 20, sometimes 30% slower than it should be. Now here is the thing that makes this particularly frustrating. On a clean, fresh Windows installation with nothing but the base system running, your CPU should idle very comfortably in that 30 to 50 degree range. But Windows is not a clean system. It is a system that accumulates services, background tasks, and scheduled processes over time. And many of those processes run exactly when you're not looking. They run on startup. They run when the machine is idle. They run when it is supposedly doing nothing. And on older hardware, on budget laptops, on machines running on spinning hard drives rather than solid-state storage, these background processes do not just raise temperatures a few degrees, they can cause sustained elevated CPU usage that drags the entire machine down. A user on Microsoft's own Q&A platform posted in 2025 that 2 specific background processes were overheating their CPU so severely that the machine crashed with a blue screen of death. The same user noted that on the identical hardware running Linux, the overheating did not occur at all. That is not a coincidence. That is the direct, measurable impact of background Windows services on a machine that should have been running cool and quiet. So let us get into the 5 features. Let us start with the one that earns the most complaints on Microsoft's own community forums, the most posts on Reddit, and the most threads on Tom's Hardware. This one has a name that most people have never heard, but a file that shows up in Task Manager for millions of people, causing mysterious CPU spikes that appear at random, run for minutes at a time, heat things up considerably, and then vanish before you can investigate. The process is called compattelrunner.exe, and it belongs to a Windows feature called Microsoft Compatibility Telemetry. Feature 1, Microsoft Compatibility. Telemetry, also known as the Connected User Experiences and Telemetry Service, also known internally as DiagTrack. What does it do? The Windows Compatibility Telemetry Service is a background process in Windows 10 and Windows 11 that collects technical data about how your device and its software are performing and sends that data to Microsoft on a scheduled basis. Microsoft describes it as a mechanism for improving the user experience and improving the quality of the Windows platform. What it actually does, from a hardware perspective, is run scheduled compatibility scans, package up diagnostic data, and transmit it to Microsoft servers. The process runs on a schedule managed by the Windows Task Scheduler, specifically under Task Scheduler Library, then Microsoft, then Windows, then Application Experience, where you will find a task called Microsoft, Compatibility Appraiser. This task is what fires compat_telrunner.x, and when it fires, it does not fire politely. Users on the official Microsoft Q and A platform have reported that Microsoft Compatibility Telemetry uses 100% of a single CPU core for several minutes at a time. One user with an 8-core 3.6 GHz CPU reported the service consuming 20% of their total CPU when the machine was supposed to be idle. Another reported it running for 30 minutes continuously on a machine that should have been quiet. The process is specifically known to spike CPU and disk usage to 100% for up to 20 minutes at startup, and some users report encountering performance issues and application crashes during these spikes. Is it safe to disable? Every credible source I found, including Microsoft's own documented guidance for Windows Home users, confirms that this service can be safely disabled. Disabling it means Microsoft cannot collect that telemetry data from your machine. The operating system continues to function. Your security updates are not affected. Your programs all still run. The telemetry collection simply stops. On older hardware, especially machines running traditional spinning hard drives rather than solid-state drives, disabling this service has helped many users eliminate the periodic slowdowns and temperature spikes that coincide with its scheduled scans. How do you disable it? Press Windows and R together to open the Run dialog. Type services.nmsc and press Enter. The Services console opens. Scroll down the alphabetical list until you find Connected User Experiences and Telemetry. Right-click it. Select Properties. Under Startup Type, open the drop-down and select Disabled. Then click Stop under Service Status. Click Apply, then OK. That removes the service from the startup sequence. Now open Task Scheduler by searching for it in the Start menu. In the left panel, navigate to Task Scheduler Library, then Microsoft, then Windows, then Application Experience. In the main panel, you will see Microsoft Compatibility Appraiser. Right-click it and select Disable. That stops the scheduled task that launches the process in the first place. Also, disable dnmwa-push svc through the Services console using the same process. These two steps together give you the most complete reduction in telemetry activity without touching the registry. If you are running Windows 11 Pro or Enterprise, you can also use the Group Policy Editor. Press Windows and R, type gpedit.c, navigate to Computer Configuration, Administrative, Templates, Windows Components, Data Collection, and Preview Builds, and set Allow Diagnostic Data to the minimum permitted level. Important note, on Windows 11 Home, you cannot fully eliminate all telemetry through settings alone. Some minimal diagnostic data, basic device specs, and error reports will still be sent to Microsoft even after these steps, but the heavy scheduled scanning and the CPU spikes that come with it will stop. Feature 2, SysMain, formerly known as Superfetch. Here's a feature that sounds useful and was useful once for a specific kind of hardware that most people do not have anymore. SysMain is a Windows background service first introduced in Windows Vista in 2007. Its job is to study your usage patterns over time, learn which applications you open most frequently, and preload those applications into your RAM before you open them. The theory is that by the time you click the icon, the app is already in memory and launches instantly. When it works, it provides a noticeably snappier experience. When Microsoft designed this feature, the world was running on traditional spinning hard drives with read speeds measured in megabytes per second. Preloading applications into RAM made sense because reading from a hard drive was genuinely slow. An SSD can read data at speeds between 500 and 7,000 megabytes per second, depending on its generation. A traditional hard drive reads at around 100 to 150 megabytes per second. Superfetch was engineered to paper over the latency of slow storage by keeping things in RAM instead. In 2026, the majority of machines built in the last 5 years use solid-state storage. On those machines, SysMain no longer provides the performance benefit it was designed to deliver. But it still runs. It still consumes RAM. It still causes CPU spikes. And on machines with limited memory, specifically machines with 8 gigabytes of RAM or less, which still represents a large portion of the world's active computers, SysMain's habit of aggressively filling available RAM with cached applications can leave the actual applications. You're actively trying to run competing for memory. This competition shows up as high CPU usage as Windows shuffles memory around, as disk activity spikes, as data gets pushed to the page file, and as elevated temperatures when the CPU works harder than it needs to for what should be simple tasks. The XDA developers analysis published in August 2025 found that on older laptops with spinning hard drive storage, Disabling SysMain eliminated the hallmark symptom of 100% background disk utilization that is extremely common with the service. On a laptop already running warm, removing that constant background disk and CPU pressure can meaningfully lower operating temperatures. The nuance here is important, and I want to give you the honest version rather than the simplified one. If you are running a modern machine with 16 gigabytes of RAM or more and a fast NVMe solid-state drive, disabling SysMain is unlikely to produce a dramatic difference. The Windows Forum analysis from April 2025 put it plainly: for most users with recent PCs, SysMain is harmless and potentially beneficial to leave on. The performance jump, while measurable, amounts to a handful of milliseconds when launching most productivity apps on modern hardware. Where it matters is on systems that are RAM constrained, storage constrained, or both. If your machine has 8 gigabytes or less of RAM, or if it is still running on a spinning hard drive, or if you are regularly seeing your fan spin loudly at idle and your temperatures are elevated for no obvious reason, disabling SysMain is a legitimate and safe thing to try. How do you disable it? Press Windows and R, type services.msc, press Enter, scroll to SysMain in the list, right-click, select Properties, change startup type to disabled, click Stop, Apply, OK. Restart your machine. Open Task Manager and observe your CPU and RAM usage at idle. If they drop noticeably, the change made a difference. If they stay about the same, you can re-enable it through the same steps by setting startup type back to automatic and clicking Start. Feature 3. Windows Search Indexing, specifically the search indexer.dexy process. This one is responsible for some of the most maddening reports on Microsoft's community forums. A user posts that their laptop is heating up badly at startup. Another says their CPU spikes to 80 or 90% usage the moment Windows boots and then slowly settles down after several minutes. Another says their fan is running at full speed while the machine appears to be doing nothing. In many of these cases, the culprit is Windows Search Indexer. Search indexer.exe is the process that powers Windows Search. Its job is to crawl through your files, your emails, your documents, your installed applications, and build an index of their contents so that when you type something into the Windows search bar, results appear instantly rather than requiring a live scan of your entire drive. The concept is sound. The execution has a well-documented problem. Microsoft's own official documentation on the topic states that on a typical user's computer, the indexer indexes fewer than 30,000 items. On a power user's computer, it might index up to 300,000 items. When indexing exceeds 400,000 items, Microsoft's own support page acknowledges that you may begin to see performance issues. The indexer can technically handle up to 1 million items, but Microsoft's documentation explicitly states that if it tries to index beyond that limit, it may fail or cause resource problems, including high usage of CPU, memory, or disk space. And the initial indexing, the first time Windows builds this index after a fresh installation or a major update, can take hours and consume significant CPU and disk resources throughout the entire process. Multiple Microsoft community posts confirm that Search Indexer.exe has been reported running at 80 to 90% CPU at startup, cooling down only after several minutes. On laptops, this sustained CPU load during startup pushes temperatures up significantly before the machine has even done anything productive. There are two approaches here depending on your needs. The first approach is to limit what gets indexed rather than disabling the service entirely. You can do this by opening the Start menu and typing indexing options, opening that window, clicking Modify, and unchecking locations you do not need Windows to index. For most people, the entire C drive does not need to be indexed. Limiting the index to your Documents folder, your desktop, and your email client reduces the scope of the indexer's work dramatically and can resolve the high CPU issue without sacrificing the ability to search your important files. The second approach is to disable Windows Search entirely. This is appropriate for people who rarely use the Windows search bar, who use a third-party search tool instead, or who have determined through Task Manager monitoring that searchindexer.exe is consistently using excessive resources on their specific machine. To disable it, press Windows and R, type services.msc, scroll to Windows Search, right-click, Properties, set Startup Type to Disabled, click Stop, Apply, OK. After a reboot, Windows Search will no longer index anything. You can still search files through File Explorer, but searches will be slower because they scan the drive in real time, rather than consulting an index. For most people who use search occasionally rather than constantly, the trade-off is worthwhile in exchange for the elimination of CPU spikes and elevated temperatures at startup. This is the category of Windows feature that sounds completely benign until you actually open the list of what is running and look at it. In Windows 10 and Windows 11, a large number of applications are granted permission by default to continue running tasks in the background even after you close them or have never opened them at all. These background tasks keep apps updated, pull in notifications, check for new messages, refresh live tile data, and perform synchronization operations. Every single one of them requires CPU cycles to do those things. On a machine with a fast processor and plenty of headroom, the individual cost of each background app is small enough to be unnoticeable. The cumulative cost of 10, 15, 20 background apps all running on a machine that is already working hard is not small. It is the difference between a CPU that idles at 35 degrees and one that idles at 55 degrees. The practical reality of background apps in 2025 and 2026 is that Windows permissions for background activity have become more granular in recent versions, giving you more control than earlier iterations of Windows offered. In Windows 11, you can manage which apps run in the background by going to Settings, then Apps, then the three-dot menu next to individual apps, selecting Advanced Options, and under Background Apps Permissions, changing the setting from Always to Power, Optimized, or Never. Setting an app to Never means it will not run any background tasks at all when you are not actively using it. The apps that most commonly generate unnecessary background CPU usage and temperatures include Mail and Calendar, which constantly polls for new messages, Xbox, which runs background activity even on machines where the owner never games, Microsoft Edge, which runs a background process even when no browser windows are open and can be disabled through Edge's own settings under System and Performance, Microsoft Teams, which historically has consumed substantial background resources, and News and Interests, which fetches content updates regardless of whether you have ever clicked on it. The correct approach is systematic rather than indiscriminate. Open Task Manager, click the Performance tab, and watch your CPU usage at idle for 2 to 3 minutes. Then open the Startup tab and examine what is set to launch with Windows. Disable every startup entry that belongs to an application you do not need running from the moment you log in. Common candidates include Spotify, Discord, Steam, OneDrive if you do not actively use it, and browser update helpers that run at login. Each one you disable removes a process that was consuming CPU cycles and generating heat during startup, often during the exact period when your machine is already working hard to load Windows itself. A clean startup with only essential services launching is one of the fastest and most impactful things you can do to reduce CPU temperatures and improve the overall responsiveness of your machine without spending a single dollar. There's a specific subset of background activity worth addressing separately. Windows notifications. Every notification that pops up on your screen, every app that alerts you to something, every badge counter that updates required the CPU to wake up, process the event, and render the notification. On a machine receiving dozens of notifications per hour from applications you do not actively monitor, this creates a background rhythm of small CPU activations that collectively raise average temperatures during idle periods. You can manage this by going to Settings, then System, then Notifications, and disabling notifications from every application you do not genuinely need to hear from immediately. The difference is not dramatic on any individual machine, but it is real, it is measurable, and combined with the other changes in this list, it contributes to a meaningfully cooler and quieter system. Before moving to the fifth feature, I want to recommend a tool that makes everything in this list easier to see and verify. It is called HW Monitor. It is made by CPUID, and it is free. HW Monitor reads the digital thermal sensor built into your CPU, the same sensor the processor uses to decide when to throttle itself, and displays real-time temperature readings for every core. Download it, open it, and leave it running in the background while you work through the changes in this list. Take a note of your CPU temperatures before you change anything. Then make each change, restart the machine, and compare. This is not about faith in a tutorial you watched on YouTube. It is about verifiable numerical evidence on your specific hardware with your specific Windows configuration. If disabling a service drops your idle CPU temperature by 8 degrees, you will see it in HW Monitor. If it makes no difference at all, you will also see that, and you will know to look elsewhere for your thermal problem. Free software, real data, no guesswork. Core Temp is an alternative that is equally well regarded and slightly simpler in its interface if HW Monitor feels overwhelming for a first-time user. Either one will give you the temperature readings you need to make this process evidence-based rather than speculative. Now, there is something deeper happening on many machines that these 5 features alone will not fix, and I want to name it clearly so you do not walk away from this video with an incomplete picture. Some machines overheat because of a software-generated CPU load that background services create. Those are the machines this video is most directly aimed at. But some machines overheat because of physical issues that no setting change can address. Dust blocking heatsink fins and fan blades, degraded thermal paste between the CPU and the cooler, a failing fan that no longer spins at the RPM it was rated for, or a laptop that is consistently placed on a surface, a bed, a couch, a carpet, that blocks the intake vents on the bottom and traps the hot exhaust air before it can escape. The way to know which category your machine falls into is temperature monitoring. If your machine hits concerning temperatures only under heavy load, and idle temperatures are in the normal 30 to 50 degree range, the issue is likely physical, cooling capacity rather than software load. If your machine runs hot, even at idle, with the fan spinning audibly when nothing demanding is running, software background services are the most probable first cause, and this list addresses them directly. The two problems can also exist simultaneously, which is why addressing the software load first, then cleaning the hardware, then checking thermal paste is the correct sequence. You eliminate each variable in order rather than guessing which one is responsible. Feature 5, Windows visual effects set to high performance, and the related power plan settings. This final entry is the most nuanced on the list because the correct setting here depends entirely on what you're trying to achieve. But for users dealing with overheating on older hardware, on budget laptops, on machines with limited CPU headroom, the combination of Windows visual effects and a poorly configured power plan can be responsible for a surprisingly significant amount of background CPU load. Let me explain both. Windows visual effects are the animations, transparency effects, shadows, and smooth transitions that make Windows look the way it does. The fade animations when windows open and close. The smooth scrolling, the live thumbnails in the taskbar, the arrow transparency. Every single one of these requires the CPU and GPU to perform calculations every time you interact with T-HE interface. On a machine with a fast dedicated GPU and a modern processor, these visual calculations are trivially cheap and completely invisible to performance. On a machine with an integrated graphics chip, working alongside a CPU that is already running warm, these same visual calculations add a persistent background GPU and CPU load that generates heat without contributing anything useful to productivity. To adjust these settings, right-click on the Start button, select System, then click Advanced System Settings on the right side. In the Performance section, click Settings. You will see 3 radio button options: Adjust for Best Appearance, Adjust for Best Performance, and Let Windows choose. Selecting Adjust for Best Performance disables all visual effects and reduces the interface to a functional, no-frills appearance. If that feels too stark, you can alternatively select Custom and keep just the specific effects you prefer while disabling the ones you do not need. The effects that consume the most resources and are safest to disable include animate windows when minimizing and maximizing, show shadows under windows, show shadows under mouse pointer, show translucent selection rectangle, and slide open combo boxes. Disabling these specific effects while keeping options like smooth edges of screen fonts enabled gives you a functional compromise between appearance and thermal performance. The power plan conversation is closely related. Windows ships with 3 default power plan options accessible through the control panel under Power Options: Balanced, Power Saver, and High Performance. A 4th option called Ultimate Performance is available on Windows 10 Pro and Windows 11 Pro through a command that adds it to the list: High Performance Mode and Ultimate. Performance mode: tell Windows to keep the CPU running at or near its maximum clock speed at all times, even when no demanding task is running. On a desktop machine with robust cooling, this is fine and provides a snappier feel for everyday tasks. On a laptop or a desktop with weaker cooling, high performance mode is essentially asking your CPU to generate as much heat as possible at all times, whether or not there's any work, justifying that heat. The balanced power plan, by contrast, adjusts the CPU's clock speed dynamically based on actual demand. When you are doing nothing demanding, balance lets the CPU relax to a lower frequency, which generates less heat and consumes less electricity. When you start a demanding task, balance ramps the CPU back up to full speed immediately. For the vast majority of users who are not running time-sensitive workloads that require instant CPU availability, balanced is the correct power plan. And switching from high performance to balanced on a laptop or a thermally limited desktop is one of the single most effective things you can do to reduce idle temperatures. If you want even more aggressive thermal management on a laptop, Power Saver goes further still, though it does so at the cost of some responsiveness in demanding tasks. There's one more thing I want to tell you before this video is done, because all 5 of the changes I described are reversible. But there is a context for doing any of this that I think matters more than the settings themselves. Every single one of these changes is most effective when combined with the most basic and most commonly neglected physical maintenance any computer owner can perform: cleaning the inside of the machine. Dust is one of the most underestimated enemies of CPU temperatures. It accumulates on heat sinks, it clogs fan blades, it blocks the airflow vents on the sides and bottom of laptops. a thin layer of dust on a CPU heatsink that would otherwise allow airflow as a thermal insulator, and insulators trap heat at. The result is a CPU running 5, 10, sometimes 15 degrees hotter than it would run on a clean heatsink with the same workload. Thermal paste, the compound between the CPU and the heatsink that transfers heat away from the processor, also degrades over time. After 3 to 4 years of heavy use, particularly on machines that run hot, thermal paste can dry out, crack, and lose its effectiveness at transferring heat. Replacing thermal paste on a desktop CPU costs under $10 and typically reduces CPU temperatures by 3 to 6 degrees Celsius on its own. On a laptop, it is a more involved process, but the thermal benefit is often even greater because laptop cooling systems have less margin to begin with. The combination of what I have described in this video works because it attacks the problem from both directions at once. You reduce the software-generated CPU load that creates unnecessary heat, and you ensure the cooling system is in the best possible condition to remove the heat that unavoidable workloads generate. Windows search. Indexer stops spiking your CPU at startup. SysMain stops filling your RAM and causing background disk churn. Microsoft compatibility. Telemetry stops running its anonymous scans during your idle time. Background apps stop waking your processor for notifications and sync operations you never asked for. Visual effects stop taxing the graphics subsystem for animations that serve no functional purpose. And underneath all of that, a clean heatsink and fresh thermal paste give your CPU every possible advantage in keeping temperatures inside the safe range where your hardware runs at its full designed capability. I want to be clear about something because clarity about this specific topic matters. None of the 5 features I described are malware. None of them are bugs. They are intentional parts of Windows designed with specific purposes. Telemetry genuinely helps Microsoft diagnose widespread software problems. SysMain genuinely helps app launch times on hard drive-based systems. Search indexing genuinely makes file search faster once the index is built. Background apps keep notifications and sync services current. Visual effects make the interface more pleasant to look at. I'm not telling you these features are evil or that Microsoft had bad intentions in building them. What I am telling you is that on a significant portion of the hardware these features run on, their cost in CPU usage, disk activity, and heat generation exceeds their benefit for the individual user in front of that machine. That is the specific problem I set out to solve, and these are the specific settings that solved it. Your machine, your hardware specs, your cooling situation, and your tolerance for trade-offs may lead you to a different set of conclusions, but the facts about what each of these processes does to your CPU are not in dispute. They are documented in Microsoft's own support database, in thousands of user reports, and in measurable temperature differences that show up the moment you disable them and watch the numbers fall. There is also a broader principle here that I think is worth stating, because it applies to every computer you will ever own, not just the one you are using right now. Every operating system, Windows included, is designed to run on the widest possible range of hardware, from the lowest spec budget device to the most powerful workstation. The default settings reflect that breadth of hardware. Features that make perfect sense on a high-end machine with 32 gigabytes of RAM, a fast processor, and a powerful cooling solution can be genuinely problematic on a 4-year-old laptop with 8 gigabytes of RAM and a single fan trying to cool everything inside a thin aluminum chassis. Microsoft cannot ship different default settings for every configuration of hardware, so they ship settings that work adequately for the middle of the hardware distribution and leave the rest for users who are willing to investigate and optimize. That is what this video is. An investigation. A set of verified, documented changes that move your machine's configuration from defaults designed for hardware you might not have towards settings calibrated for the hardware you actually own. The 5 changes in this video are not hacks. They are the settings your machine was waiting for you to discover. One final thing. After you make these changes, after your temperatures drop and your fan gets quieter and your machine feels more responsive at idle, the temptation is to keep going, to find more things to disable, more services to turn off, more registry keys to modify. There's an entire corner of the internet devoted to Windows debloating that goes far deeper than anything in this video. Some of those changes are legitimate and well documented. Some of them break things in ways that are genuinely difficult to reverse. The 5 features in this video are specifically chosen because they are documented, reversible, and have a verified track record of improving thermal performance without creating instability. Before going further than what I have described, take a system restore point, research each additional change thoroughly, and be confident you understand what each service does before you disable it. Windows is a complex system with many interdependencies, and not every background process that looks unnecessary from the outside actually is. The 5 I named today are safe. Beyond them, proceed carefully and verify everything. Open Task Manager right now. Click on the CPU column to sort processes by CPU usage. Watch it for 5 minutes at idle. What you see running at the top of that list, what is consuming your processor, raising your temperatures, and spinning your fan while you're doing absolutely nothing, that is the answer to whether any of this applies to your machine. If the list is clean and your temperatures are comfortable, you may not need any of these changes. But if the list shows background window services chewing through 10, 20, 30% of your CPU while you're just sitting there, you now know exactly what to do about it. And your CPU, running cooler, quieter, and without the constant drag of processes that serve someone else's interests more than yours, will thank you for every single one of them.